in this video I am going to discuss test based on carboxylic acid and derivative. First question, this compound with SO2Cl2 acid give acid chloride, OH is replaced by Cl, and HydraClCl3. So just we'll write the structure: benzene, CH2 benzene, and at ortho position there is COOH. So in the first step, OH is replaced by Cl. In the second step, anhydrous there is formation of carbocation and cyclization. So compound B will be this one, and the last step is Clemmensen reduction, which will reduce CO group. So correct answer is C. Next question. Ethine having acidic hydrogen when react with the Grignard reagent, first will give methane, and compound A will be another Grignard reagent, and CO2 water will introduce COOH group. So compound B will be this one, C. Next is toluene on oxidation gives benzoic acid. With SOCl2 give benzoyl chloride. With NaN3 it give azide, acyl azide. Nucleophilic substitution. Now on heating, azide will lose nitrogen and then rearrangement. Rearrangement is by phenyl shift. So product will be isocyanate. Isocyanate are stable in neutral medium. So answer will be phenyl isocyanate. In acidic and basic medium, it will be changed into amine. But now the answer will be phenyl isocyanate. Next is which decarboxylate easily. Decarboxylation is based on stability of carbon ion. In case of first, carbon ion is resonance stabilized. Which is not possible in rest of the cases. So it will decarboxylate easily. Next is out of propanoic, propyne, chloropropanoic, 2-propanol. The compound having most positive pKa is 2-chloropropanoic acid. This reaction is false because 2-chloropropanoic acid is most acidic, and acidic strength is inversely proportional to pKa. So this will have lowest pKa. So first statement is false. Second is ethane has strongest conjugate base out of following. Yes, ethane is weakest acid, so its conjugate base will be the strongest one. Rest are more acidic. So second statement is true. So correct answer is B. Next is find the end product. So you have to confirm whether the end product is correct or not. In case of first, bromine NaOH, it is Hofmann-bromamide reaction, will give amine. And on heating, there is internal nucleophilic substitution. So yes, it is correct, true. In case of second, dilute KMnO4. With the dilute KMnO4, there is hydroxylation, syn hydroxylation. With periodate oxidation, this bond will break and one more OH will be added on both sides, methyl, and this bond breaks this bond will break with the periodate. This bond breaks to give this dione. With the basic medium, there is aldol condensation. And in aldol condensation, this methyl group will attack over here. CH2 group will attack on this carbon and O changes into OH. And after elimination, this product will be so second is also correct. So both are true. It is C. Diol formation, periodate, then intramolecular aldol reaction. Seventh question. Acidic strength, order of acidic strength. CF3 exerts strong minus I, methoxy weaker minus I, 1-methyl donating, 2-methyl more donating. Yes, first statement is correct. Second is reactivity of different nucleophiles Z in this reaction. Stronger the nucleophile, faster will be the reaction. So NH2 is the strongest one, then OH, then OCOCH3, because in OCOCH3 there is resonance. So both the statements are correct. Next is the boiling point of propionic acid is less than that of normal butyl alcohol, an alcohol of comparable molecular mass. So carboxylic acids have stronger hydrogen bonding, so boiling points are higher. And Kolb electrolysis of potassium butyrate. This is potassium butyrate. Sorry, in the first propionic acid of boiling point of propionic acid is more because it has stronger hydrogen bonding. So first statement is wrong, so it is false. But the second statement is correct because this dot and this dot combine to give hexane. So first is false, second is true. Ninth, mercury chloride is reduced to mercurous chloride by formic acid. Formic acid has aldehyde group and it is the reducing agent. It is oxidized by mercuric ion into CO2 and changes mercuric to mercurous. So it is A. This is the reaction. And ultimately mercurous will change into mercury. Next is Grignard agent when react with CO2, MgCl replaced by COOH. Now further reaction is HVZ reaction. Alpha hydrogen is replaced by Br. With aqueous KOH, Br is replaced by OH. So the product will be alpha hydroxy acid. Product is alpha hydroxy acid. So correct answer is A option is this one is C. But the last step is dichromate, oxidation by dichromate. Dichromate will oxidize OH into CO. So after last step, answer will be alpha keto acid. 11th question. This is an ester. With NaOH, there is deesterification. And product will be sodium salt of acid plus ethanol. And after acidification, the sodium salt changes into COOH. With the LaH, ester is reduced to alcohol. With the nickel hydrogen, benzene ring will be reduced. And nickel hydrogen can also reduce ester group. So correct answer is A. This on acidification gave acid. Next question. Ether C6H14O when heated with excess of hot HI gives 2 alkyl halide which on hydrolysis gave 2 different compound. This is A, gives B and C. sorry, A gives two halides with HI, and these halide on hydrolysis give alcohol, which will be B and C, where B on oxidation give acid and C on oxidation give ketone. That means C is secondary alcohol and B is primary alcohol. So out of these options, B and C should be secondary alcohol and B should be primary alcohol. So first A option will be correct. Like in A, with HI, ethyl iodide and butyl iodide. And ethyl iodide on hydrolysis gave primary alcohol and this gives secondary alcohol. This on oxidation gave ethanoic acid and this on oxidation gave ketone. In second case, these are not correct, and in the third case, option C option is also correct, because in C option this ether will give 2 iodide. This iodide on hydrolysis give primary alcohol. This will give secondary alcohol. On oxidation it give acid. On oxidation it give ketone. So both the options are correct, A and C. Next is acetate ion is more basic than methoxide ion. This statement is wrong because acetic acid is stronger acid than methanol. So acetate ion will be weaker base than methoxide ion. Acetate ion is resonance stabilized. It is correct. So answer will be D. Next is acetyl chloride is more reactive towards nucleophilic substitution in comparison to acetamide. This one is correct because Cl is a good leaving group and it has a weak electron donating effect. Resonance effect is weak, electron donating effect is weak, so it is a good leaving group. So it is half of the reason, so answer will be A. Next is acetamides are strongly basic in nature. This is wrong. They are weaker base. It is because of resonance. Lone pair is delocalized. And basic character is due to lone pair. So second is correct, but first is wrong, so it is D. Next is pK value of acetic acid is lower than phenol. This is correct because acetic acid is stronger acid than phenol. Phenoxide ion is more resonance stabilized. This one is wrong because in phenoxide ion, in resonating structure, negative charge is delocalized on carbon. Whereas in a carboxylate ion, negative charge is delocalized on oxygen and its resonating structures are equivalent. So second statement is wrong. So it is C. Next in paragraph, what is the product when acetic acid react with 1-butanol in presence of acid catalyst? It is esterification reaction. So acetic acid and 1-butanol will give butyl acetate, that is C. If a scientist wished to obtain methyl ester from carboxylic acid, what reaction conditions would favor the product? In esterification, which is reversible, excess alcohol will favor this reaction to forward direction. So if carboxylic acid is added to methanol, it will favor the forward reaction, not the backward reaction. So acid should be added. Third question, when the tetrahedral intermediate returned to the carboxylic acid, reaction is, this was the tetrahedral intermediate. Let me check it in the paragraph. This is the tetrahedral intermediate. So when it returned to carboxylic acid, that is C double bond OH, this OH group should be, this OR group should be first protonated. We can say this H will protonate OR, after positive charge it become a good leaving group. So leaving group will be an alcohol, not the hydroxide ion or alkoxide ion, because they are not good leaving group. Next is end product of this reaction. First step is HVZ. Alcoholic KOH causes elimination. With NaOH it is decarboxylation, so answer will be B, alkene. Next is, first step is again HVZ. Second step is hydrolysis, and it is alpha hydroxy acid. In alpha hydroxy acid there is intermolecular esterification, like this. And answer will be C. Next is limited red phosphorus, that means one alpha hydrogen is replaced by Br. With aqueous KOH, B will be optically active compound. C will be, with ammonia, Br is replaced by NH2 and acid changes into amide. With the KCN, Br replaced by Cn. So out of these answers, only B is optically active. This is wrong. C and D are optically active. Yes, it is correct. B and C are optically active. Only D, no. So correct one is, this one is also correct. B and C are optically active. And C and D are optically active. So both B and C are correct. Oh, sorry. D is inactive because there is hydrolysis also. So Cn changes into acid group. So this carbon will not be chiral. So D is not optically active. So answer will be C. Both B and C are optically active. KCN is followed by hydrolysis. So Cn will be changed into COOH. Now passage 3, which is most acidic. You know very well that 3-chlorine will make it most acidic and it will have lowest pK value. Why does this compound has greater pKa than the second one? Because chlorine is further from COOH, so it will exert less minus I effect and less acidic. And that is why its pK value will be higher. So correct answer is C. What would be expected pK value of 2,2-dichloroethanoic acid? 2,2-dichloroethanoic acid will be in between trichloro and monochloro. So according to the paragraph, this value should be in between these two. So it will be 1.26. Next is, you have to match it with the pK, with the Ka values. Highest Ka for third. and the most acidic is second. So third will match with the 2. Match of third with 2, which is in B. And after this, it is third. Second match will be this. And the third one will be after this. And it is, no, this will match with fourth. Second will match with the second, and this benzoic acid will match with fourth. Fourth match with the first. And methoxy will be the weakest. And then 5. So correct answer is B. Order of acidic strength is 2, then 3, then 1, then 5th, then 4th. 4th will have lowest pK value. Next question, more than one answer. Which of the following statements are true about formic acid? It is stronger than, yes, because methyl exert plus I effect. It formed formyl chloride with PCl5. No, because formyl chloride is unstable. It readily breaks into CO plus HCl. It gives CO and H2O on heating with concentrated H2SO4. Yes, sulfuric acid, there is dehydration and product will be CO and H2O. And yes, it is a reducing agent and will reduce tolerance reagent. So ACD will be correct. Second is, what is the correct order? Ease of hydrolysis. This statement is wrong because anhydride hydrolyzes faster than ester. Because in anhydride, leaving group is OCOCH3 and its parent acid, acetic acid, is stronger acid. So it's a good leaving group than OR group. Second is acidic strength. Yes, formic, benzoic and acetic. This one is the correct order. And third one is also correct. Fluorine exert more minus I. And acidic strength, 4 methoxybenzoic acid is the weaker one because methoxy exert plus M effect. Then benzoic acid. Then 4 nitrobenzoic acid minus I and minus M. And 2 nitro groups exert more minus I and minus M. So yes, C, D, B, C, D are correct. Which test is given by both formaldehyde and formic acid? Fouling solution, Benedict reagent and tolerance reagent. And the last test is shown by only formic, not by formaldehyde. Benzoic acid is weaker than nitrobenzoic acid because withdrawing group is there, but stronger than toluic acid. In toluic acid, there is methyl group which exert donating effect. So it is weaker than benzoic. So correct answer is B. Acetic and formic. Formic is, benzoic acid is not weaker than acetic. So this one is wrong. First one is wrong. And benzoic acid is weaker than formic acid. This is correct, but stronger than acetic. This is also correct. So B and D are correct.